Um, Even the duration is 2.5. We have documentation covered for this section. Online, there is everything, the sample code, which is much easy to understand and prototype. Okay, so we are going to discuss the lesson 5 in section 2, which is the lesson on specific topic. Today we are going to discuss access of geometrical information through Symmetron API, which are the API responsible for accessing the information, geometrical information. Okay, so if you found like if something is not clear for you, just stop me at that point and show me. Okay, so I'm sharing my screen. Okay, so first thing what we have to do is we have to create console application. Okay, so today I'm using 22. So what I can do is I can create console application. Maybe I don't have that, so I'm exporting my template for 22. Symmetron 22 API C# console. Then click the click, start and take one example folder path we already have created, right? In API session, this is session 5. Session 5. Okay, morning. Okay, morning. So I'm selecting this folder. Okay, then let's create. So I hope you all are familiar with the geometry. Let me show you something. Okay, I'm opening the API online help document, and here you can see our document. Here we have Symmetron API. Here are two main sections. One of the section is this geometrical information. If I expand this, you can see a nice chart here. This chart for the section of API displayed below. Click on the items, jump to the help topic. Okay. What is here? Okay. So this is the diagram where you can see the geometrical information. We have body. Inside body, we can get iGeom3 body, and it has geometry 3D. Okay. So if I click on geometry 3D, so you can see this is geometry 3D, and it has some basic APIs to calculate volume, center, box, projection area, and surface area. Okay. So in the same way, we have geometry for point, curve, and faces. For the curve and faces, you can see four classes. So basically, for the faces, we know like face can be a plane, sphere, cone, torus, or general spline face. Okay, so these are like hidden. So this is like under development. So we are not going to the details of mesh and STM. And for the curve might be straight line, ellipse, or the curves, the like spline curve. Okay, so and also we have geometrical service. The geometrical service is responsible for geometrical operations. Like in geom service, you can see. Okay, if I go inside the geom service, you can see there are many APIs like calculate minimum distance, surface area, project body surface area, project bodies, body center, advanced compare, like this. Okay. And in the LM callback, you can see the LM callback hmm, is um, is something like you can get facet type of information. So this is LM right now. It is not documented. We are in process of documentation. We'll do that. Okay, and advanced compare. This is documented. If I open it, you can see the properties and the documentation, how we can use the advanced compare. Okay, so today our focus is on this area, geometrical information. So let's take a look, right? Okay, Symmetron is open. I am creating new part. Okay, I have some plugins here. So let's draw something. Maybe I can draw a slot. Okay, and create this extrude. So I have this solid object. You can see here is a one body. Okay, so if I want to select faces, this face filter, and I can select. We want this information programmatically. That's why I show you like here spaces, edges, and bodies. Okay, so let's try. So this template is created. Let's try to build. Okay, it is asking for admin rights to build. Okay, this is admin rights. Okay, so build successful. Admin rights succeeded the build. So then our next step is like to open this existing part, right? So first I have to save this part. So I'm going to save this in this session file. My name, I can say like demo part. You can create your own demo part, no problem. So I have to find path of this, right? So editor. Oh, it goes to second screen. Okay. So for opening the document, we know we have PDM which is responsible for opening documents. So I am opening the document. I am giving the file path to open the document. Okay, I lost my path. File path. Okay, that file is in C10 online lectures course file. Okay, project is open. And this demo part. Okay, so this is the demo part. Then it will give me the document, right? So our next problem is to collect all bodies on this part, and then we can check the geometry of each body. Okay, so for that we can use our online help. Here already the code is present, so I'm opening this geom body, and you can see here is a code. Here you can see the body is taken from ID. We already know how to take from the ID, but we also know that how we can query body um, from the filter, right? So let's try to use filter. So to use filter, what we have to do, we first have to use or get the document model. So this is the model, and let's check if the model is able to cast in the query or not. So I am going to object. Here is the model. Here is MDLR model. Okay, so MDLR model is going to be cast in our entity query. This is the MDLR model. So let's cast into the entity query. Face API, entity query. Okay, so this is the query, and we have to create filter, right? So create filter. So we can create filter for body type, entity type. Where is entity type? Entity type. Okay. So let's check the filter, entity filter. Entity, sorry, I filter entity, something like that. I filter entity, entity. I entity filter. Okay, I entity filter. Okay, so this filter, then we can add the necessary information to filter. Let's check what we have to use. We have to give the type, right? So let's give the type. So which kind of, oh, what is the type here? And entity, oh, 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 oh. I think it's the base class of everyone, right? It is not like the main class. So let's check the entity type. What will return the entity type? Let's go to the document. Where is the filter? Here's filter, filter type, filter by type, filter type. Okay, so here we have class filter type. Filter type, filter type. So we have to cast this into the filter, right? So the class explicitly, and here is AND function, and the input of AND is entity type. So which kind of entity we are interested into the body, right? So body. Then we have to add this filter, sorry, set filter inside the query, and let's run the query. So we know to get entity from the query, first we have to select, then it will give the list. Okay, so I entity filter, this is filter, then it has select function, which return the icing entity list. I entity, okay, icing entity list, all entity, all bodies. Okay, this is good till now. So if you have question, just ask me. Okay, so this code is actually to create entity filter for body and get the body out of the filter from the filter. So I'm going to add this in a function because we want to use this again and again today. So what I'm going to do is get entities of type, entities of type. So I'm copying this code from here to here. Okay, return type is obviously the entity list. Okay, so return the bodies. Okay, and we have to supply the MDLR model. So MDLR model is our input. Then our second input is this, the entity type, because we might be interested in the some other type for the next time. So I am adding this as type. Okay, so this is our function which is responsible for get entities of given type. So I'm going to erase all this code from here to here. Okay, so return type of this function is the bodies. So bodies, and I have to give the MDLR model first, then the body type. Okay, so let's check, and then we have to take one each body, right? So we know like the list is start from one, so started from all, otherwise it will give a crash. Okay, I'm going to cast each entity into the ISIM entity. This all thing we already did in our previous lecture session, so I'm um, not explaining it in details because we already did it. But if you want the details, then let me know. Okay, so this is the entity, and we are at this point like we can find our entity as body. Okay, and till this code, the entity. Then we can copy this code. The code is much simple. Each entity has geometry, right? So geometry. Okay, what happened? Okay, this is in base. So there's base. So geometry, and geometry can cast into the 3D body, because we are taken example of body. So what is our graph? Our graph is this, the geometry and 3D body. So I am doing the same thing here. Okay, then we can take some what you say, things which is available like the volume. Okay, this is in double value, volume is double volume. Okay, you can even take the area, surface area. Okay, then I am trying to show this area in the console. So I'm console, right line, volume, to string, console, surface area line. Okay, so perfect. So I'm adding string like volume is equal to like this volume, and this is surface area. Okay, so now this is perfect. I'm going to build and then try to run. So we already have Symmetron launched, everything is ready, and part is here. Okay, so let's try to debug. Okay, so it gives an exception, this file already open, right? Because we already opened it. So what we have to do is, first, in the last, I think, plugin, we did that. First, in the for the application, we have to ask, do you have any active document? Okay, it is expected that document application give me the open document. If it is not open, then we will try to open. Then if the application is null, okay, then I think this will remove. Okay, build in admin, and let's try again. Okay, so you can see we fast this, we get the active document which is open, then we got the list of bodies. We have one, oh, it's two bodies. Oh, one is wire body, because we have sketch. So if I open this, We have wire body and solid body. So let's check what we have. We have geometry. Okay, let's take the area is none and surface area is 0. This is because we cast it into the body. Okay, so why the previous value is none and 0? Because in the symmetron we have right now ideally we have two body when the object is one. One is this, the wire frame, the wire body, we call it as wire body. Second one this, which has faces, edges, which has volume, sphere. So to separate this or to identify this in the API, we have one option. Okay, so let's stop here. Okay, so we know already like this is the body. Okay, so we directly cast into the geometry, but we can also cast into the some topological object. So we have eye body. Okay, and we can cast it into the body. Each entity it is casted into the respective topology object. Okay, so let me explain this bit. This is new. Where is the so we have taken this section geometry, but in the book we have topology, right? If I open this, you can see it is a topology object. So which kind of topology object we have? Body, faces, loop, edge, vertices, point, wire, wedge. If you are not familiar with this, just look at this. Like this is a solid, it has body. This is a body, okay, and this is a face. Loop is something like you can consider this can take like outer boundary, outer edges, in sequence like close sequence. So this is close, this is loop, okay. Vertices like each edge has some vertices start and end, so vertices. The edge like each face is bounded with edges, so the green is edges. Okay, so this is topology object. If you see here the body, I mean everything in the topology is can cast in the ISIM entity everywhere. In the body, it is also ISIM entity. So we already know we filter only body. So obviously this is body. We can cast this directly into the body. Okay, and if I ask this body like is wireframe or not, it will show me like this is wireframe or not. So it has function like is close wire or sorry is wire. So is wire is basically gives me an information the if this is wire or not. So let's try this is wire. So I can specifically ask my program don't look for the wire. So if wire is 0, that means it is not wire, means it is solid, then I can try to execute my program. Okay, so let's try to build it again. Okay, then try to debug. Now you can see the first is wire 1. We are not going to check for wire. Then second one is the real body. You can see the 0, the solid body. And here is geometry. You can see the volume, the depth, and the surface area. And if I write in console, it is going to be right. Okay, I have to add here console write line to stay window. Sorry, console read line. Okay, so this is like how you can access the geometry of body, and how you can play around with the body geometry. So I'm adding good comment here. Body geometry. So anyone has any question? Hello. So I'm writing my whole code in the chat, and let's take a break for 2 minutes to execute this. Make sure like in your Symmetron you must have body somewhere, otherwise it will give some crash this program. Okay, so I'm setting clock for 2 minutes, right? Anyone tried this example? Chain mod MGT. uh, Okay, no problem. We can go ahead and just make sure you have to try this when you have free time, right? So let's check the paces. Okay. So for the faces, first thing we have to do is we have to take the every face. So we have function. We just have to give at syn face as the input. It will return all face. So the output is all faces. Then again we have to start the loop. Okay, so I'm just copying the first loop. Okay, it starts from faces. So faces. Okay, the next thing is in the above we have cast into the body, eye body. So we must cast into the eye face. This is face, so eye face, a face. Okay, so if I take a look inside a face, it has only argument of set formatter, which is responsible for tessellation. Okay, we are not going to check today tessellation. This is not in the scope. We must have to gain some precision knowledge before that. I will try to cover it maybe in the next series if it is planned. Okay, so this is the faces. So how to check the geometry? So let's check. So we can just copy this. Okay. I am copy the entity I have cast into geometry. But do you think I can cast it into the 3D job? So let's check. Right, we have a nice chart. So we are discussing about the page, and page can be cast into the iGeom 3D. Okay. Uh, okay, so let's check iGeom 3D surface. So here, by mistakenly curve written, but it is surface actually. I will correct this after our meeting, or it might take like 1 week to replicate the changes in website. But it must be a geometry. The face has surface geometry, not curve geometry. So geometry can cast into the surface. Okay. So let's check what we have inside surface. So inside surface, you can see the test point, get parameter by point, is planar, is parametric, is normal, the face operation. Okay. So let's take one example like curvature. Okay, so for curvature, we have to give some kind of parameters. Okay, and for parameters, we must know its limit. So let's take the limit. And the limit, if I check the limit, so uh, yeah, I jump 3 seconds. Okay, limit is double array. You can see the double array. Okay, so double limits, and it has like minimum min v, min max v. So we must write like this. This is a double array. Don't worry. Okay. Then the option like double u min is first one. Double v min is second one. Then u max. Then v max. Okay. Visual Studio 22 is much intelligent. It doesn't play recommend the next one. Okay, so this is the limits of that surface. Each surface can be defined in the some parametric limit. If you don't know, you can check it in, you just Google it. And that limit we can represent in two values like u and min, and u must be min and max because it has some range. Okay. So we can take the midpoint. So like u mid. Okay. So sorry, u mid. So what is the mid? How we can do like u min plus u max. Okay. And as this is mid, we just divide this into two. Okay. Then the same way we can do for the v. Okay, v mid. So we can ask the curvature for u mid, and v mid. So it has some return type. Let's take as it is, or maybe we can take it from the website, right? It is much convenient. So where is curvature? The curvature. Oh, it has this value. So you can see the object is actually the double value. This is actually the double, and this is out. So let's check. Okay. So let's try to build program. Then try to execute. Okay. So we are here to the face geometry, and you can see how many faces we have. Six faces. Let's check. One, two, three, four, five, and six. It's correct. Six faces. Then take each face. You can see it cast into the face, it cast into geometry, it cast into the surface geometry, and if you check, like it has ID, surface type, true, right? It give me the limit. Limit is like this. This is minimum u, min v, max v, max v. So I took midpoint. It is somewhere between u min and u max. Okay, it is much near to the zero. Let's try to check the curvature. And if you can check the curvature, c0 is 0 and it's 0, and the curvature direction is 1 and 1. So in this way you can fetch any geometrical properties and geometry of face. Okay, this is one example to fetch the curvature. Okay, I hope this is good, right? As I said, today's session is much simple for me. I just have to copy the code and show to you, because most of the thing is documented very well. Okay, then the next thing which we can do, like we can check how we can determine this is face, sphere, or cone. Okay, so where we are here, and if you check here, it gives some type. Let's check surface type. Okay, so it return one value which is geom surface type. So we must have to take the geom surface type. Geom surface type. Okay. Okay, so we can use the switch case, as this is enum. If I paste this enum and type enter, you can see this. The surface can be plane, sphere, cone, torus, spline. Okay, so let's check if it is plane. We maybe can cast it into the plane, because we have special class for the plane, iGeom 3D plane. This class is special because you can take the geometrical information, plain geometrical information, right? So it's take, so this is plane. If it is plane, so what happened? Okay, so we have to give the geometry. Okay, if it is plane, then you can access the information. You can see the plane. Plane has its root point, base point, normal, direction, because these two, three things is enough to define a plane. Let's take the normal. Okay, so normal can cast into the double array. So I'm going to cast it into the normal, and this can be as double array. Okay, so you can check in between to access the geometry of surface, cone, torus, spline. Okay, so I'm going to compile this in admin rights and try to execute the program. Let's try to debug. F10, 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 F10. So this is, you can see the normal. Normal is 001, means Z direction. Okay, so if you want to see this plane, actually you can take the ID. Geometrical ID is 18, and if you select this entity by ID, and you will get that plane. So let's take, this might be, okay, I think this is this ID 18. So let's check. Entity information, it's 18, 18. Perfect. I directly select this because it give me the Z direction as a normal. So only this page has Z normal in this model. Okay, so I hope this is good till now. Let's talk about the curve. Curve and faces is much more similar. Okay. So first thing is, as usual, we have to take all curves. So for that we must give like the curves, and you can say it don't have the curves, but you can ask to give all edges, because at the end body has edges which internally represent a curve. All edges. Okay, so then take this code just as it is for the face. We can modify it for curve. Let's check IH. It's topology. So IH, H. Okay, and now it is not surface because edge has curve, right? So I3D curve. Okay, and it's geometrical body. So if I ask the like curve type, it give me the some curve type, right? So let's take how many. So the curve can be straight, ellipse. Int curve is like spline, and composite curve. Okay, so we can check for straight line. So inside this, the way we took, like we cast it into a specific geometry, we can do the same. We can cast this into a iGeom straight. We have straight. So this is straight line, straight curve, and we can ask to like get direction. It has direction as property, and direction mostly a double array everywhere. Direction. Let's cast this into the array. Okay, and you can also take any geom sorry 3D curve properties, right? So it has many property. We can take actually like start end point, right? That might be simple. So let's take start. Okay, and no, we must take this yes curve as geometry, and then ask like end point. Okay, so we have to make sure like which object is this, the end point. So for that I am going to the curve. Inside curve, here is straight. I take the straight and curve. Then the end point. Oh, where is the point? Okay, end point. So it is the double array. So let's take this as array end point. Okay, so let's try to execute this, right? First build in the admin mode. So okay, so we are at phase we already covered. Okay, so we ask all the edges to symmetron. It give me the edges. It must be 16. Yes, 16 edges. Then I take each edge I cast into the geom curve. It casted. I asked for the type and it is straight, right? It is going to straight. I cast into straight and asked for the direction. So it give me the direction. This is the curve direction, edge direction. I break it and I ask the end point. So it give me the end point. So the edges is like this. If you hover on these filter sketches, okay, filter edges and curve. If I open only this, you can see all the selected items is actually the edges. This. So we took one edge and try to get the properties and values of that edge. Okay. Hmm. So this is okay. So let's move to the last section of today's agenda, which is the point. Okay. For point, it is much simple because a point is point, right? So let's take um, what we can take. We maybe take vertices. Yes, vertex. So in geometry, vertex, the edge has two vertex, the start and end. So this vertex can have this point, can be represented in the point. So we took the all vertices. Okay, then try to get each vertex. Okay, this is all vertex, this is sim entity, and this is I vertex. Yes, thank you. So this is a single vertex inside body. Okay, so the usual thing is same. Only thing is like here is curve is not present. We shift to the some sections, right? So here instead of curve, it is a jump point. Okay, and if I take a look inside jump point, what is properties available? You can see it has only x, y, z, nothing else. So let's x, y, z, and you must define like some nice name. Double x, sorry, x. This is z and this is y. That's it. Okay, what happened? Okay, it is equal to z remaining, right? Okay. Okay, so let's try to compile program again and try to add a breakpoint here. Okay, and start. Oh, what happened? Oh, I got entity list 0 for vertex. Oh, it it should give the vertices, right? Let's take point. Okay, so I think the vertices, it should give the vertices. I will check for the vertices why it is not coming. But for these sessions, for the understanding of point, we can create some points on some edges. To create that, I think we have one function points on curve. So let's do, I can create 5 points. Oh, I have to choose the star. That's okay. And let's check. Okay, you can see I got the 6 point, and as usual this cannot be cast into the vertices because this is not vertex, this is point, right? I have to modify my program, um, and let's recheck again. This is ICM entity, the geometry class. So why it is not given? Let's check. Okay, okay. This is because even this is like entity, but it has geometry. You can't cast it because you have to go with some topological rule. Okay, so so forget about this. This is kind of bug for me. Like we can't access the vertices and do prototypes. Okay, so I will check this, but and try to add in upcoming version. Okay, so I am going to remove this. Okay, so this is the code. This code is responsible for getting the geometry of bodies, faces, and edges. Okay, so for the vertices, actually we have made our topology structure in API stronger than today. So it will going to be released in the upcoming version 23, where you can access the vertices, you can ask for the edges, give me your vertex, and like that. Okay, so let's take a break. 5 minutes break. Then we can go ahead with the next section of today's lesson. Okay, creating the customized command. Okay, so I have given you the code in the chart. So try to build and try to fill to get geometry access to the symmetron. Hello, hello. Sorry, it's hello. Hello. Sorry for the delay. One emergency. So let's talk. Anyone tried this code to access geometry? Mud, MGT, Jason, have you tried this? Hello. Okay, so no problem. Silence is a good answer. Mm, okay, so try whenever you have free time. We can move it for our next topic. Okay, so I'm closing all these sample. Maybe for the reference, I can give you the sample code. Okay, so our next top actually the today's the topic which I have to cover according to the calendar is covered. I have one assignment for you. I can give you the some broad idea. Okay. So let's close this. Actually, I have created this assignment in development version, but I will give you some code and you have to try it on 25. Okay. So what is the assignment? So let's first open. So assignment is this. You have to create a rectangle in sorry, rectangle, it is not rectangle, it's cuboid. Okay. Means simply what you have to do, like you have to draw a rectangle and extrude it with some value. The name of this is incorrect, but don't go with the name. The concept is same. You have to create rectangle and extrude. Okay. So for that, I will share this code, the complete code. Okay. What you have to do? You have to read this code, try to debug, and there is one problem inside this code. You have to fix that. Okay. So I can give you some broad view idea. So this is a com command. So I hope you everyone is aware about this. We covered it in the second lesson. So this is com command. This is a command class. The enable, execute, and this. The name of this command is rectangle. It is under shape object. Okay. So whenever user click on this command, it hit the execute button, and inside the execute button, I have created a feature guide. You must have to take a look how to how what I say how you can create a custom feature guide. Why this is I have created, because in the 3 hours it is we are not able to cover everything for the custom guide, and it might be very fast for you, uh, and some of you may feel like it is very slow based upon the coding experience in C sharp. So what I did, I have created code for you. I have added everything, the feature, stages, apply button, everything. You have to learn this, okay, and you have to fix one problem. Okay, so let's talk. So you can see after registering this command, you can see one button inside shape. You can find one button, this rectangle. Okay, this rectangle button can be added, and to register this command, what you have to do, you have to go to the Symmetron installation folder, C program files 25. Oh, sorry, C program files. I don't have program files. Okay, so C program file, Symmetron 25 program, and inside you just have to search register API command. You must open this exe in admin rights. Without admin rights, this program will not register. So run as administrator. Okay, select the exe path. Okay, so you must have to put this DLL. Okay, you must have to put this DLL inside the program, otherwise it will not going to load. So where is that? Okay, okay. So you have to select this DLL, and you can see the many classes here, but you have to select this rectangle mycom command, and I will share you that code. So where is that code actually? The Symmetron plugins. Okay, and his rectangle. You have to select this icon. Okay, I don't have icon here, so let me show you that. So you have to give the icon files. Here is icon file. Okay, then try to register API command. After that, reopen the Symmetron, and you can see this command is loaded here. When you press on this command, one nice feature guide which is responsible for create rectangle and extrude is loaded inside the Symmetron. It is created through plugins. Okay, in C sharp. You must have to understand how I have created this. Then you can see here the select point on the screen. It is written like user guide message, the way inside Symmetron we do. So I have selected the point. Then automatically the second step enable and active. It asked me about the cube length. Actually, this is rectangle length, the XYZ delta, where I have to translate this. Okay, and press OK. After pressing OK, you can see a cube is created with the value. Okay, so rectangle can be square when the all sides are equal. So what you have to do? You have to create a cube. Okay, and the problem is like this command created a rectangle and then extrude. So what you have to do? You have to fix this. First, you have to draw a square. Okay, with all the inputs and extrude it. Okay, so I know you already know how to debug this. If you are not able to debug, just let me know. I will show you one class where everything is managed, and I will draw one broad level diagram for you. So we have feature creator. Uh, so in this, let's open draw. Mhm. I'm not able to draw everything correctly, but I will give you some broad idea. So we have feature creator. The class name is most likely the same, might be some kind of difference, but it is okay. Feature guide creator. We have this class. This class is responsible for creating a feature guide inside Symmetron. Okay, and to handle and to maintain our own feature guide, we have feature feature guide. Okay, so to handle this feature guide, we have our own stages like FG stage 1. So FG, okay, FG underscore stage 1. Oh, FG underscore stage 1 underscore stage 2. Okay, this feature guide contain these two objects. Okay, feature guide is it. And we have feature data, which is responsible for holding the all data when user click and give the value, delta value. Okay, so at the end, this feature data is in action while creating a feature inside Symmetron. So this is feature data. Okay, so what is the steps? Steps are like in feature guide, create a feature with stages, activate the first stage, this one, then we pick point, then stage 2 is enabled. When we press OK, during the changes, we update this feature data, and when we press OK, we ask feature data to create feature and add into the Symmetron. Okay, and when we try to edit, the edit callback hits here, and the code of the edit callback is not completed. The expected is like you can trace all the feature data which is already created and set and update this feature data. And while feature guide creator, you must use this feature guide feature data. Okay, so that you can edit on the data which user created that feature means queue. Okay, so this is the exercise for you. So I will share this code with you. If anyone has question, just ask me, or maybe I can share this. And in between, even if you have any question regarding this, just mail me. I will answer you. Is it okay for all? Okay. Your silence, I assume this is okay for you. Okay, so I'm stopping this screen and concluding the today's session. My what I want from you from this exercise, you have to obviously repair this code. The repair means you have to understand the structure, how to create feature guide, how to create stages, and how to create the data and how the feature creation is responsible inside Symmetron. Okay, so my agenda is you must have to know by checking the code how the feature guide going to create inside Symmetron. Unless and until you try, the next session is very hard for you. Okay, the whole session is around this exercise. So you must have to do, you must have to debug this, you must have to understand this. Okay, so this session is concluded. So thank you for joining. I will make sure I will share this whole code with you. Okay, everyone, thank you for joining. So I'm stopped the recording. The details is added in the chat. We can go through that, and in between, if you have any question regarding this,